Yo, what's up, everyone? Good morning. Happy you're here. Crap. um, and this time I didn't even lie on the worksheet. It's Friday, so I'm super behind. I let myself slip a little bit in algebra at the end of the year, but I think it's fine. You guys seem to appreciate me for who I am, so that's awesome. um, and I've been kind of stressed about the AP exam for statistics. That always kind of happens at the end of the year. Get really dialed into that. So I've been working on that, but I've also been figuring out the end of the class for algebra. And the reason I'm going to push and even send out a Friday problem set is, and I'm going to announce this to everyone in next week, but I'll tell you guys because you're actually watching. Week 9 next week is going to be our last week of content. Woo! um, so I figured out how to finish the year in 3 more lessons. So this lesson, and then we'll have 2 problem sets next week and a quiz. Um, so if we miss this lesson, we wouldn't finish next week. But if we finish next week, that's going to give you a week and a half to catch up on old work. So you guys are probably my ballers if you're listening, and that'll just mean that you get to kind of end the year early after next week. But I'm really big on trying to get everyone to pass. So we're gonna end next week, and then there'll be a whole free week, like pretty much no work in June. So I'm pretty stoked for the plan, and we are gonna graph these functions. So I'm really proud of us for how far we got. My voice, I'm not crying or anything. I don't know what's with my voice. Maybe it's just the morning. Okay. With that being said, all of the lessons for the rest of the year are going to be pretty tricky. So dial into that, but also really useful. These are some of the wackiest math concepts. They're not they're so common. You've probably, if you haven't heard the word radians, I mean, you're early in your education, so maybe you haven't, but radians are a common phrase. Um, and the unit circle is really common as well in the rest of your math career. Okay. So, what we're going to do today is really weird. It's really bizarre, but I think we're going to make sense of it, and it's going to be helpful next week when we graph. Okay, so what we're learning about is what's called radians. So first, I want us to kind of reference this circle for A. It says, what is the circumference of a circle? And then how many degrees is a circle? So this is tying us back to like elementary geometry. And all I'm asking is, what is the formula for a circle, right? And maybe you do or you don't remember. We have pi. Even I'm trying to remember it now. I haven't even thought about it too much yet. But there's pi r squared, and that's the area of a circle. So the area equals pi r squared. And then hopefully remember that the circumference is 2 pi r. Okay, so the circumference of a circle is 2 pi r. And what that means is that if you're traveling around a circle, whatever the radius is, you multiply that by 2 pi. Okay, so for the unit circle, what we already know, and I'll sketch a random one here. What we know is that the radius of my unit circle is 1. So the circumference of this unit circle is just going to be 2 pi, right? The radius is 1. Crap. I've got to get used to writing the pi symbol. And the glare has been so bad. We'll be fine. But the circumference of the unit circle is 2 pi. Okay, so hopefully that makes sense to everyone. So if you travel around the unit circle, the distance is 2 pi. So what we're going to start visualizing is if the entire circle is 2 pi, then 1/4 of the circle is or like half of the circle is pi, 1/4 of the circle is going to be half of pi. So that's what I want you to start visualizing. So the circumference of a circle is 2 pi, and then it's also how many degrees, right? And this is something that you know from real life. A circle, and we already talked about this, is 360 degrees, right? If you're going to make a full turn, a full flip, you're doing 360 degrees. 180 means you turn yourself completely around, but 360 is the entire circle, right? Right. And we already know this from before, right? Because we know we go 1/4 of the way, and that's like 90 degrees. We keep going, it's 180 degrees. We've talked about this a lot, how like this would be like 45, etc. So the big thing that we're going to do is we recognize that there's two measurements of the circle. That's kind of our big first idea. We can measure it with degrees, which we've already been doing, but we're going to start measuring it in pi, okay? And that's what a radian is. So for B, it says sketch the angle 90 degrees on the unit circle below. And if a circle is 2 pi, 90 degrees is what distance of the circle. And we're going to use this information to convert 90 degrees to radians. So I've already kind of been doing this in my explanation. But remember that 90 degrees is going to be here on the circle. And let me erase the old one. And if we have 90, it's not going to be like a triangle. Already twice. Them. Because the entire line is up, right? So the x is 0 and the y is 1 because we're directly above. So what we're going to do, and I've already kind of explained this, is these are going to start being two different measurements of the exact same thing, okay? So if we have a 90-degree angle, we want to convert that to radians, or how far along the circumference we are, right? So again, visualize that the whole circle is 2. Half of the circle is 1 pi. So sorry, the whole circle is 2 pi. Half the circle is 1 pi. So for half of the circle, we're going to be half of pi, right? So let me write that in. The most basic radians, and you can, I mean, it kind of looks like a clock right now, but 90 degrees is half of pi. 180 degrees would be pi, right? 270 is going to be 3 halves of pi. Okay, so half a pi, pi, 1.5 pi. So 1.5 pi, we're going to write as 3/2 pi. And then finally, if you made it all the way around the circle, so you made the whole journey, it would be 2 pi. Okay, so that's the big idea. We're going to convert degrees to radians. So this one is going to be half of pi. Now, before we proceed, we're going to do the formula so that you know how to easily convert, okay? So if you go from degrees to radians, and it's really simple, you're just going to divide by 180, and then you're going to throw pi in there, okay? So the other way, if you have radians, 2 degrees, you multiply by 180. So in the context of this one, and we'll use the phone calculator, and we're going to have even more application to this in a second. 90 was pretty easy because it's one of these on one of the axes. But if I wanted to know how many radians it is, all I'm going to do is take the degrees and divide by 180. So the harder part is it's going to be a decimal and we want to convert to a fraction. Like fractions are more common. But 0.5 is 1/2. So we're 1/2 pi. Let's do the next one. But that's pretty much the gist of today's lesson. We're going to really apply it next week. But that's the big thing, converting radians to degrees. Okay. So for C, it says sketch the angle 135 degrees on the unit circle below. And then we're going to convert to radians and find the coordinates. So we want to find the coordinates for this point as well. That's what we're building towards. But we're doing 135. So we want to sketch this. And if we're sketching this, know that 90, 180. So it's going to be in this quadrant. And you can even kind of know exactly what it's going to be by doing 135 minus 90. Okay, so it's gonna be like 45, if that makes sense. So that's the point. Think 90 plus 45 would give us this. And to find the coordinates, we're going to plug in basically sine 45 or sine 135 and cosine 135. So that's going to be the same. But we want to convert this to radians first. Okay, so all we have to do that is take 135 and divide by 180. Okay, and you're going to start getting some slightly harder answers now, and we're going to talk about kind of how to round it. So 135 divided by 80, which is 0.75. And like you could write 0.75 pi. That's the correct answer. But it's not the right answer because we like to use fractions for radians. Okay, so you're always going to see it in a fraction. So your kind of basic fraction work, we have to be like, hopefully we're good at. 0.75 is 3/4, right? And you can even visualize that. So we're going to write this as 3 pi over 4. Okay. You always include the pi. Okay. So think that a full 180 would be 1 pi. So we're 3/4 of the way to a full 1 pi. Perfect. Okay. So that is how we could convert 135 to radians. We just divided by 180. But now we want to find these coordinates. And we're going to use this to kind of expand what we know. We know that to find this side, we can, and this is weird, but this is like a 135-degree angle on the unit circle. So if we wanted to plug it in over here, we would do sine 135 for the opposite, for so. And then if we wanted to find the bottom, the adjacent, it's going to be cosine 135. So that's what we learned last time. But I'm going to show you something cool. And it is a little, it's going to seem a little silly now, but first, like 135 sine 0.707, cosine of 135 is also going to be 0.707, but negative this time. And that makes sense because we're going negative. So we could write our coordinates here as 0.707 comma negative 0.707. But what we're going to start doing is you can solve these using pi. So actually, let's just do this next one, and I'll show you what I mean. Here it says to sketch 7 pi over 4 and find the coordinates. So the first thing to realize is that you could be asked to plug in a degrees, but from now on, you could also just be asked to plug in a radians. Okay, so 7 over 4, if you ever get really confused, you could do the division and see it's 1.75. But a lot of these are kind of going to repeat, and think that 8 over 4 would be the full way. So 7 over 4 is going to be 7/8 of the way to the end. So I did that part really quickly. But you just have to start getting used to converting. So actually, let's talk about how, if you didn't know that this was going to be over here, if you want to convert this to degrees, all you're going to do is multiply 7 over 4 by 180. Okay, so you divide degrees to radians, multiply now for radians to degrees. So we have 7 over 4, and we're going to multiply that by 180, and it tells us it's 315. So that's good to know because we're in this quadrant because this is 360, this is 270. So this is where we are. But let's say we didn't have it converted and we just wanted to find the coordinates. Here's the big thing. the coordinates are always going to be sine the angle and then cosine the angle. But if you have the angle in radians, you can also plug that in to your calculator. So they're both going to give you the same answer. So in this case, we started with the 7 pi over 4. So we're going to talk about how we could convert on our calculator. So we're going to use another new thing on the phone calculator. And you see rad on the bottom right, sorry, the bottom left. If you do rad, that stands for radians, and it'll say radians up here. So let's just show 315 sine is the answer, negative 0.707, meaning that we're down negative 0.707. But if we turn it to radians, we can take 7. There's pi, 7 pi over 4. So 0.785, and then press sine. And this time it was positive. Let me try that again. Okay, I figured out what I did. So silly. I was about to be like upset because I was confused. But we have to do 7 multiplied by pi. Maybe people notice that. And then divide by 4. I was like so confused. So this number, sine, is also going to give us negative 0.707. And we could do the exact same thing for cosine, 7 pi over 4. Okay, so 7 times pi over 4. The cosine of that number gives us the same value. Okay, so these are equivalent statements. That's the big gist for today. Degrees and radians are equivalent, and we're going to get pretty familiar answers here. So that's pretty much the last big part of the lesson. And I know it's kind of bizarre, but if you showed this to anyone in your life, they're going to be like, oh yeah, that is something that came up in the future math, or anyone who did like a lot of STEM work. It's going to come up a lot in your future math classes. This last one, all we're going to do, and this is how we're going to start your practice problems when I write them, is practice converting degrees to radians and vice versa. Okay, so you can always visualize the unit circle, but there's the formula that we know, and that's kind of the best part of this. We have the degrees, and all we're going to do is 30 divided by 180. And the only part of this that I kind of think is worth worrying about is converting this to fractions. Some calculators do that. Oh crap, this is important. But actually, make sure you're not always in radians, and you see the opposite's degree, right? So that's kind of how you know you're doing the right thing. We're at point, crap. 1666, and it was 30 over 180. And I feel kind of bad because I can't figure out a better way to explain this, but we want to convert this to a fraction, and that's 1/6. Okay, so that's going to be pi over 6. And all I can say is like maybe keep in the back of your mind that you're going to want to convert these to fractions, and then hopefully your fraction work is decent enough that you can be familiar with a lot of these, because like 1/6 is 0.16666. Okay, 5 pi over 6, all we're going to do is multiply this by 180. So radians to degrees is actually really easy. Here's 5 over 6, and then multiply that by 180, and it's going to be 150. So radians to degrees is really easy. Let's work through a few more of these. Like those are going to be super easy. So I want to do the degree ones. 240 divided by 180 is 1.333. So I'll go through my process of kind of putting this. Oh man, they're doing stuff downstairs. I'm so close to done. Okay, 240 divided by 160 is 1.333 pi. And 0.3333 is 1/3, right? So this is going to be 1 1/3. And we want to write that in an improper fraction. Okay, you're never going to see 1 1/3 pi. You're always going to see it in an improper fraction. And the bottom numbers are always like 2, 3, 4, 6, or 12. Okay, unless you have a super bizarre one like this last one. You're going to get familiar with the common radians. Just like 240 degrees, 30 degrees are common degrees to get. These are the common radians. As a last one, this is actually stupid. I don't even know why I did it. We have 3 or 6. So if you have any really random number, you can still convert it to radians, but you might not get a clean answer. So we actually got 1.7, which is much cleaner than you'd expect. And that's okay. And if we're just going to do some really quick improper fraction work, we could convert that to 17 over 10 pi. 17 over 10 is a 1.7. So that would be like the proper way to write this, but you're probably not going to be asked to do anything with something like that. But so that's the big idea there. Let me just finish this because we're here. If we wanted to go radians 2 degrees, super simple. We just multiply by 180. So, this might be like something to talk about. Pi over 4 just means 1 over 4, right? Because there's no number but pi on the top. And you ignore pi when you're multiplying to 180, right? 5 over 6 times 180. We didn't do 5 pi over 6 equals 180. Think that you include the pi with radians and then you just kind of get rid of it for degrees. So 0.25 multiplied by 180. This is going to be a 45 degree angle. And then here, 7 over 12. The strat should be convert to the number first and then just multiply to 180. So 105 degrees. Alrighty, guys. I really appreciate you for watching this lesson whenever you watch it. I'm sending out on a Friday, so you have a lot of leeway in getting it done. Just make sure you get it done before June. I appreciate you. 2 more lessons, 1 more quiz, and then we're out, folks. I appreciate you and proud of you.